Okay, so friends, in this series of algorithms, in last video, if you remember, this was the thing which I discussed, like to find out the diameter of a binary search tree, or you can say the binary tree. I have taken the binary search tree, but it can be a binary tree as well. I hope you understand the difference between a binary tree and a binary search tree. Okay, so in case of binary search tree, every left node is smaller than the root node, and every right node is greater than the root node, right? But in case of binary tree, this restriction is not there. Okay, so this video you can go through, and on my channel you can just go to the playlist of algorithms. Yeah, this is data structure algorithms, and here you can go and you can check the latest one. The latest one was diameter of a binary search tree in this playlist. Okay, so this one you can go there and search there, and I have explained like how to find out the diameter of
Hello
a binary
friends,
search
in
tree.
this
So
series
today I'm
of
just going to explain it like how we can write the code to find out the diameter of the tree. Okay, so diameter, I hope if you go through that particular video which I have shown you, if you go through that video, then you will be able to understand that what is the meaning of diameter of a tree. Okay, so here what I have done, this is the set of data. This is an array of 9 elements using which I have created my own binary search tree. And then here I am just inserting all the nodes, and this is the insert node function which I have written here. I'm not going to explain like how I have written the binary search tree insertion algorithm, because this has been explained earlier in one of the videos, right? So my whole purpose, the only purpose here is to find out to write the logic as how to find out the diameter of the tree, diameter of the binary tree, or you can say the binary search tree. Okay, so here I have inserted it all the nodes, and then I have written a function display the diameter of tree. So this is the function display the diameter of the tree. So here you can see like I have just passed the pointer to the root. In this function display the diameter of tree, I have just passed the uh, pointer to the root of this BST. And here what I'm doing, I'm just trying to find out the height of the left subtree from the root, right? So if I have made a tree like this, then in this case, this is the root, and this is the root of left subtree. In fact, this is the entire left subtree, and this is the root of left subtree. So I have passed the root of the left subtree from the root. Okay, so this root becomes a new subtree in itself, which is the left subtree of the original subtree, original tree, original binary search tree, or you can say the original binary tree. Okay, similarly, then I have find out the height of the tree from root for the right subtree. So this one, let me just, this one is the right subtree of this entire tree, and this is the root of the right subtree of this entire binary search tree. So I have passed this one here, and I have found out the height of the left subtree and then the height of the right subtree. You know that the height is like the maximum depth. Okay, so height is basically the maximum depth, means the maximum number of nodes, 1 2 3, and here also it's 1 2 3, right? But please remember that this is not the example that I have used here. So here you will be able to see some difference in the results. But I hope you know, if I'm right, you are able to understand like what is about what I'm trying to explain here. Okay. So this is left subtree and this is right subtree, and I will find out the height of both the subtrees, and then after finding the maximum depth of both the left and right subtrees, I will just add 1. Why I will add 1? Because I am leaving this root, right? I am trying to find out the height of this and height of this, but I need to count this root as well. So at the end, after finding the height of left subtree and right subtree, I will add 1 to the result. So here what I have done, see out the diameter of the tree is left height plus right height plus 1, right? So this will give me the correct result. And what is the data with me? This is the data with 5, 12, 2, 1, 3, 21, 25, 9, 19. Okay. Okay, so To make it simple, I think I can place this one, but I hope you are able to understand now. I could have taken it's my mistake, I could have taken the example same, but I hope you know that how to create a binary search tree using any data. So I hope you can create the binary search tree using this set of data, this set of elements in the array, and then you will be able to understand like how the height of the left and right subtree can be found, and then how we can add 1 to that, and you can see that what is the maximum number of nodes in a particular path. I mean the diameter of the binary search tree. So here is the function, and this is the original function which is trying to find out the height of the tree. This function is always the same, just like height of tree from root. We have to find out the height of tree from root. So for that we don't care whether it's left or right, we just take a root, and based on that we try to find out the height of the left subtree, then try to find out the height of the right subtree, and whatever height is higher we return that. Okay, so suppose if we come here, then you can see that there are two subtrees. The left subtree is there, the height of the left subtree is 2, there are 2 elements, and the height of the right subtree is 1, 2, 3. So what will be the result? Left subtree height is only 2, but the right subtree height is 3. So the height of the left subtree will be 3, because this one is maximum. The depth is maximum here, 2, 3, 4 for the right subtree. Okay. Similarly, in case of right subtree, the maximum depth is 1, 2, 3. 1, 2, 3. Both are equal, so it will return L height, right height. So it will be 3 plus 3, and then plus 1. It should become 7. Right. So although the data is different, I was giving you the example with respect to this one. Here my data is different, so here you can see a different result, but concept is same. Okay, so I hope you understand this. So if you want to see it closely, I am just opening it for you, and you can stop the video and you can see like what is the logic of this particular function, and then you can understand like how it has been written and how it will give you the results. I hope that you understand the recursive functions, and I hope that you understand the concept of height of a tree, right? Because I'm not going to explain those things, because this particular session, this particular class is not for letting you know that how to find out the height or what is the recursion. It's like a simple algorithm I'm going to write where I'm implementing to find out the diameter of a binary search tree. So the requirements are like you should know what is recursion, and you should know what is the meaning of height of a tree, right? And I hope I have explained the height of a tree. What does the height of a tree means? Okay, so here is my data, and now let's execute it. Just press F5, and I have placed a breakpoint here in the function display the diameter of the tree. So the control will stop here, and then we will see that how it proceeds. So here you go, and let's see what the height will come out. So here you have stopped. So I have passed the root node, and here I will try to find out the height of the left subtree. The height of the left subtree came out to be 2, and the right subtree height came out to be 3, right? But please remember that this is my data. The data which you can see here, this is not the data that I'm using, right? So that's why the results are different. The diameter of the tree will be L height plus R height 2 plus 3 plus 1. It means 6. So you will be able to see on the output window that the diameter of the tree is 6. This has been shown as 6, right? So this is the way you can find out the diameter of a tree, right? To get more details like what is the meaning of a diameter tree, I have already explained that you have to go to this video, diameter of a binary tree. Okay guys, so this is all for today, and we will meet soon in the next video. And in the next video I will try to explain some other algorithm related to the binary search trees or any other topic, and I will try to explain the same algorithm using the dynamic programming as well, which is more effective, and the runtime in case of dynamic programming, in case of dynamic algorithms, the runtime is better. compared to this one, right? So we will discuss that one as well. So till then, have a nice day. Bye bye, and please like, subscribe my channel and share the videos. Bye bye.